Hello, everyone. My name is Roland Martinez,
And my name is Alec Tolentino.
and today we are going to present to you our project in ECE 122L, section E02. And the project is to design a BPSK modulator and Demodulator circuit using LTSpice. So, what is a PSK? PSK is phase shift keying, or the digital modulation technique in which the phase of the carrier signal is changed by varying the sine and cosine inputs at a particular time. So PSK technique is widely used for wireless LANs, biometric, contactless operations, along with RFID and Bluetooth communications. So PSK is of two types, which are the BPSK, or phase reversal keying, and QPSK, or four phase reversals, such as 0 degree, 90 degrees, 180 degrees, and 270 degrees. So in BPSK, it is basically a double-side band suppressed carrier modulation scheme for message being the digital information. This is also called as two-phase PSK, or phase reversal keying. In this technique, the sine wave carrier takes two phase reversals, such as 0 degree and 180 degrees. So what you can see on the screen is the BPSK output signal, wherein the carrier signal is a sinusoidal wave, and the modulating signal or modulating wave is a pulse, wherein the signal is in 0 or 1, or off or on. Then the output is a modulated signal, which at every transition of a pulse, the phase is reversed. So you can see in the output on modulated signal, at the transition in reference with the pulse, the phase is reversed. Then going back to the original waveform. So on the right side is the simple input signal, or the modulating signal, wherein input is a binary sequence. Then the output is the BPSK output signal. So the BPSK modulator is the modulation of BPSK is done using a balance modulator, which multiplies the two signals applied at the input. The two signals are the carrier signal and the pulse signal. For a zero binary input, the phase will be 0 in degree. And for a high input, the phase reversal is of 180 degrees. Then the output sine wave of the modulator will be the direct input carrier, or the inverted 180 degrees phase shifted input carrier, which is a function of the data signal. So what you can see on the screen is the block diagram of the BPSK modulator circuit. So again, it uses a balance modulator, where the input are carrier wave generator and the other input is the binary sequence or data. Then the output will be a PSK wave. So what you can see on the screen is the BPSK demodulator, where the PSK signal is the input for the demodulator with the carrier signal that is a sinusoidal input. Then the block diagram on the screen is a BPSK demodulator, consists of a mixer with local oscillator circuit and a bandpass filter, a two-input detector circuit. Again, the inputs are the sine wave and the BPSK demodulator. In this process, the BPSK is recovering the original message signal, or the pulse signal that we introduced in the BPSK modulator. And the band-limited message signal will, with the help of the mixer circuit and the bandpass filter. the first stage of the demodulation gets completed. So you can see on the screen, there is 2 stages for the BPSK demodulator, stage 1 and stage 2. So again, the first stage is the translation back to baseband with recovery of band limited message. Then at the second stage, the regeneration from the band limited waveform back to the binary bit stream. As you can see, the pulse is in square wave. Then on this stage, the translation is back to baseband requires a local synchronized carrier. So in this project, the required procedure is to generate a BPSK signal for the part 1 by creating the BPSK modulator circuit given in the manual, which you can see on the figure below. Then using the LTSpice as the simulation tool for the BPSK modulator. Then showing the inputs and the outputs of the modulated or the BPSK modulator circuit, and taking screenshots of the process in the LTSpice and pasting on the documentation. Next is to design and simulate a BPSK demodulator or demodulate a BPSK signal for the part 2. So again, we design a BPSK demodulator circuit using the LTSpice. Then we use the output from the BPSK modulator circuit as our input for the demodulator circuit in part 2 to recover the original message signal or the intelligence signal. Then again, take screenshots of the complete circuit and the inputs and outputs and pasting it in our documentation. Then upload everything we used in this activity in our shared drive. So before proceeding to the activity results and outputs or the interpretation of results, we will going to show you our time lapse for the design and simulation of LTSpice for BPSK modulation and demodulation circuit. Hi there, my name is Roland Martinez, and this is a video demonstration of the project in ACE 122L section E02. And the project is to design and simulate a BPSK modulator and demodulator circuit. So let's get right into it. So this is the modulator circuit for the BPSK signal. So this is the carrier signal and this is the modulating signal. So this is the output of the BPSK signal. So to simulate, need to click the run button. So clicking the carrier signal and the modulating signal and the output signal. So this is the BPSK signal in red sinusoidal wave with a phase shift key on the part of the transition of pulse for the modulating signal. So next is to build the demodulator circuit for this BPSK modulator circuit. So now I already built the modulator circuit for the BPSK signal. So this is the carrier signal for the BPSK demodulator circuit, and the BPSK signal will be fed into the same up amp for the demodulation process. Then this circuit will demodulate then this circuit will demodulate this BPSK signal input to get the original or the intelligent signal, which is the modulating signal, that is a pulse. So we can run the schematic by clicking the run button and again selecting the inputs for the demodulator circuit. So this is the input, which is a BPSK signal, and this is the carrier signal, which is in the blue sinusoidal wave. And to differentiate between the modulating signal input and the BPSK demodulated signal, we need to add a additional plane. So selecting the BPSK original signal, which is a modulating signal, and the BPSK demodulated signal, you can see that there is a very small error in the output or the demodulated signal, since the circuit is not perfect. So but they are the same in amplitude, and a small phase is observed in the output signal. So that's the result of this BPSK modulator and the modulator circuit. Thank you.
Good day, everyone. My name is Alec Tolentino, and I will be demonstrating and discussing about Activity 8, which is about about our project, which is the BPSK modulator and BPSK demodulator circuit. So the objective of the project is to generate and to modulate a BPSK signal using LTSpice. So a quick discussion. Phase shift keying, or PSK, is a digital modulation technique that sends digital data using an analog carrier signal. In PSK, the phase of the carrier is varied by the digital information, while the amplitude and frequency of the carrier remains constant. Binary phase shift keying, or BPSK, is a form of PSK where the output is either in phase or 180 degrees out of phase with the reference carrier signal. So, the first step for the procedures is to generate a BPSK signal. So we need to create the BPSK modulator circuit, which was given to generate a BPSK signal using LTSpice. So I will now be creating the circuit in LTSpice. So now simulating the circuit for the BPSK signal circuit. So we produced a BPSK signal, then using feeding it into the modulator circuit. This is the modulating circuit. Then this is the BPSK. Then for the output of the demodulated BPSK, we have the output. So that is all for my demonstration and discussion. Thank you. So continuing on with the discussion for as we can see in this figure is the our BPSK modulation circuit and the modulation circuit. So on the upper part is our modulator circuit and on the lower part is our demodulator. So as we can see in the modulator circuit, uh, the modulating signal and the carrier signal are inputted into a multiplier, which here is we use a op amp for multiplying these two inputs and resulting into an output of a BPSK signal. Then for the demodulator circuit, we the output BPSK signal from the modulator circuit is fed into the modulator circuit along with a um, carrier signal which is inputted into a op amp which signals this is the first stage as discussed earlier where the where the original signal is being recovered, then it is fed into the second stage of the circuit where the binary signal is being recovered as discussed earlier. Then the output for the output is the modulated signal. So this is the BPSK modulator as I discussed earlier. We just get to look at a closer angle. So the modulating signal, the carrier signal is fed again into the multiplier, which results into an output of a BPSK signal. Then these are the simulated results for the BPSK modulator signal. So the lower part for the green labeled graph is the modulating signal, which is a binary form in which starts in a low input, then transitions into a high output, then transitions back to low input, then high input. Then for the middle part, the blue labeled graph is the carrier signal with a peak-to-peak value of 5 volts. Then when these two inputs are inputted into the op amp, which functions as a multiplier, we get the output results, which is the BPSK signal, which is labeled red, or on the upper part of the graph. So as we can see, when the modulating signal transitions from low input to high input, the uh, the phase of the signal is reverses. So as we can see, from 0 to 1, the phase reverses as seen on the graph of the BPSK signal. Then again, when transitioning from high input to low input, the phase again reverses. Then when it transitions again from low input to high input, the phase of the BPSK signal reverses again. So next, we get a closer look at our BPSK demodulator signal. So the output from the modulators BPSK modulator circuit is fed into this demodulator circuit along with a carrier signal which are both fed into an op amp which functions as the first phase of the recovering of the original signal. Then uh, using the output from the first phase, it is fed into the second phase where the second phase recovers the original binary signal, which results into an output of the demodulated signal. So as we can see here, The green labeled graph is the modulating carrier signal, which is inputted along with the output of the modulator circuit, which is the blue labeled. That is the output from the BPSK modulator circuit, which is then fed into the first phase along with the carrier signal, then receiving the output from the first phase, then feeding it into the second phase. We get the output of the demodulated signal, which is the red label graph. As we can see, the original binary graph is recovered by using the demodulating circuit. So again, then the green is the modulating signal in the demodulator circuit. Then the blue is the recovered original binary signal using the demodulating circuit. So to conclude this project, BPSK is a form of PSK where the output is either in phase or 180 degrees out of phase with the reference carrier signal. So uh, the polarity will be reversed every time the bit stream changes polarity. So as we saw in the output graphs earlier, uh, when the binary input is transitioning from a low output to a high output, the polarity is getting reversed every time it changes from high output to low input, or vice versa, low input to high input. Then the wave shape is symmetrical at each phase transition. Then binary phase shift keying is the most straightforward type of PSK, where binary refers to the use of two phase offsets, logic high or logic low. Then a BPSK demodulator circuit consists of primarily of two function blocks, which is a multiplier and an integrator. These two components produces a signal that corresponds to the original binary data. Uh, it is an important difference between analog demodulation and analog demodulation. So concluding, BPSK is a special type of PSK wherein the phase of the carrier signal is being varied only in two ways. Therefore, it can only be either 0 or 180-degree phase shift. Therefore, the output signal is just either in phase with the carrier or negatively out of phase with the carrier signal. And that is all for our report, for our discussion, for our project 2. Thank you.